Hello, in this lesson, we are going to talk about counting principles. So, counting principle helps us understand how many ways an event can occur. So let's say, for example, if I have an event A, which can occur in M ways, and event B, which can occur in N ways, event A and B can occur in M by N ways, which becomes M N. Let me show you with an example. Let us say you have 3 trousers. You have one black trouser, a blue one, and a gray one. And then you have 4 shirts, a purple one, a red, green, and yellow. So, how many ways can you combine these trousers and shirts to get a unique outfit? So in this case, I can say I can do a combination of M ways for the trousers and N ways for the shirts. So from there, we can do the first combination where the black trouser can be worn by the purple shirt, can also be worn by the red shirt, can also be worn by the gray shirt, or can be worn by the yellow shirt. At the same time, we can do the second combination where the blue trouser can still be worn by the purple shirt, or the red one, the green one, or the yellow one. At the same way, for the gray trouser, you can wear it with the purple shirt, the red shirt, the green one, and the yellow one. So, the trousers can have 3 combinations, which are event 1, event 2, and event 3. So, our hem becomes 3. Then our hen is the number of ways we can combine these trousers with the shirts. And as you can see from the combination, each trouser can be combined with the shirts in 4 different ways. For example, the black trouser can be combined with either of the shirts, either purple, red, green, or yellow. These are 4 combinations. Same with the blue trouser and same with the gray trouser. So the shirts combination can happen in 4 different ways. So from there, the total number of outfits you can get from these combinations will be hem, which represents the number of combinations for the trousers, multiplied by hen, which represents the number of combinations of the shirts. So it will be 3 by 4, which will be 12. So from this, you can get 12 unique outfits. Can we do another example? Where, in this case, a restaurant has 3 main dishes. So these 3 main dishes, we can give the dishes as M, we can assign them N, and then it also has around 4 types of drinks. So those types of drinks, we can give them N. And then you are told, if you choose 1 main dish and 1 drink, how many ways or how many different meal combinations can you order? So in this case, you already know you have 3 main dishes, which is chicken, beef, and fish. So you can combine those 3 dishes in 3 ways because they are 3. But then each of these dishes, 3 dishes, can be combined with either of the drinks. So let me show you. For example, you can take chicken with juice, with soda, with tea, or with water. And the same way, you can take beef, which is the second main dish, with juice, with soda, with tea, or with water. The same way you can take fish, which is the third main dish, with juice, with soda, with tea, or with water. So in this case, these drinks can be combined in 4 different ways for each of the main dishes. So in this case, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So our combination for drinks becomes 4. The total combination or the total number of dishes you can order from these then will be 3 for the main dishes, which I got from counting the number of events 1, 2, 3, then multiplied by 4, which are the number of drinks, the way you can combine them with the main dishes, and of course it's 4, so it becomes 12. So you can get a combination of 12 different types of orders or of food from this combination. But our question would arise, why do you have to do all this multiplication and even counting? Well, you can just do it manually like this and then count the outcome. In this case, we are at a very lower level. We have just 3 combinations, 3 main dishes, for example, and 4 drinks. That is very easy to do. But imagine you are given an event which can occur in almost, let's say, even 500 ways, and we call it event M, and then event N can occur in around, let's say, even 100 ways. So doing this manually will be so hectic because it means for you to get the total combination of these 2 events, which will be M by N, it will mean then you have 500 by 100, which will be something like 50,000 possible combinations. So in this case, doing this manually will be so hectic, and that's why we go for the formula itself. Let me show you. Let's assume we have a dice, a fair dice which we want to toss twice. And as we all know, a dice has 6 sides. It has 6 numbers which have equal chance of appearing given that the dice is fair. So somebody is telling you to do the total combination of to tell him the possible total number of combination you can get from this dice. So you see that will be a lot of hectic work because honestly doing a 6 by 6 combination, it will take quite some time. Taking one will combine with 2, will combine with 3, all the way to 6 combining 6. That will be a lot of work. Let me show you. You see, here I'm just trying to combine them well, but you see this machine doing it sounds very easy. But if you are to do it manually, it will take you quite some time. So instead of doing all this, why can't we just pick the possible outcomes of the first toss, which is either of these can occur, 1, 2, 3, 4, 5, 6, any of them can occur. So we have possible, we can give M for the first toss to be 6 because either of the numbers can occur. Then we have the second toss, this one, it is also 6. So any of the numbers can occur, and then we have the total number of events which can occur here are 6 by 6, which is M by N, which is 6. That's 6. These are the total number of possible combinations from this one. So as you have noted, did you realize that in all these examples, what I've done, I've taken the number of possible rows and multiplied by the number of possible columns. The columns are these ones and rows are this one, sorry. the same way I did here. I took the number of possible rows, which were the number of possible rows, which were, of course, 4, 1, 2, 3, 4, and then the number of possible columns, which were 1, 2, 3. So I got 12, then the other one I got 36. So that's the logic of counting principles. Let us meet in the next lesson.